Relations and Functions, Class 12, Exercise 1.1. Determine whether each of the following is reflexive, symmetric, transitive. So this is the first question and fifth sub-question. In that, it is A. Relation R is the set A of human beings in a town at a particular time given by R is equals to XY, where X and Y work at the same place. See, in each and every question, the common thing is you should know the set that is given to you and how the relation has been defined. So let us write what is the set they have given. The set they have defined here is set of human beings in a town at a particular time. Okay, so let us just take one example. A is equals to, let us say, M is a person, O is some person, P is some person, like that. Okay, so there are all the people who are working in a same town at a particular time. Now, how the relation is being defined? The relation is defined as the set of ordered pairs XY such that X and Y work at the same place. Okay, so the property they have defined here. So let us understand this property clearly. So here they have given that set A is a set of all human beings in a particular town. So I'll just name them. Let us say Rani, Tony, and so on. So they are some set of people. We know it will be a finite set because we can count the number of people in a given location, right? So let us say Rani, Tony, and there are some people working at a particular place. And how it is being defined is we have to take two people at a time who are working at the same place. These are the people in the town. Okay, and here we have to check who are working at the same place. Okay, so the property they have given that X and Y work at the same place. Suppose X is some person, Y is some person. So we have to make a relation of those people who are working at the same place. So here, let us take Rani and Tony. Okay, if Rani and Tony, they work at the same place. So if they're working at the same place, then how do we write ordered pair? Rani and Tony. So they will belong to this set. Okay, Rani, Tony. Let us say that already they have given M and N. So if already an ordered pair exists in this relation, then it is taken for granted that M, N, they work in the same place. So we have the ordered pair Mn. So it's like if the property is given to you, you have to check whether they are working at the same place every time. Okay, if already there is an ordered pair, it clearly implies that they are working at the same place. For example, suppose if you have the element like P and Q, it is obvious that P and Q work at the same place. Okay, suppose now you have Z and P. Z and P, you know that both are working at the same place, then clearly you can write Z and P here. Okay, so here R contains all those ordered pairs where the two people work at the same place. Okay, so if they are working at the same place, then they belong to R. If they belong to R, that means they have to work at the same place. Now we will see all the three conditions, that is reflexive, symmetric and transitive. Okay, so what is reflective here? Reflexive relation states that if A comma A belongs to, what is the set here we have defined as A. So if A comma A belongs to A for all, so belongs to R for all A belonging to A. So ordered pair always belongs to relation, and this one element always belongs to a set. So let us see that if it is reflexive. Okay, so if it is reflexive, we know that let A belongs to A. We know that A comma A is the same person working at the same place, right? Same person, obviously they work at the same place. So clearly we can write A comma A belongs to the relation R. So if A comma A belongs to R, we can say R is reflexive, right? R is reflexive. So if you want to check here, so we know that Rani and Rani, let us say they are the same people. Rani and Rani, obviously they work at the same place. So clearly we can write Rani, and this ordered pair belongs to the relation Rani and Rani. Okay, that's why it is reflexive. Same person, obviously they work at the same place. Okay, now let us check for the whether it is symmetric. So if AB belongs to R implies BA belongs to R for all AB belongs to the given set A. So this one we can take for granted. We have to check whether, we have to prove whether BA belongs to R. So let us take this granted part. If AB belongs to R, that means if AB belongs to R, that means A and B work at the same place. Implies A and B work at the same place. If they belongs to R, obviously they have to work at the same place. So what we have to prove is BA belongs to R. That is, B and A work at the same place. This is what we have to prove. Right? So it doesn't matter. Like A and B or B and A. Both are same person. So obviously B and A work at the same place. So BA belongs to R. So what we can conclude here is that R is symmetric. So if Rani and Tony work at the same place, it doesn't make any difference to say that Tony and Rani work at the same place. So it is symmetric. Now let us go for the third one, transitive. If AB belongs to R and BC belongs to R, we have to prove that AC belongs to R for all A, B, C belongs to A. So we can take these two as granted and we have to prove this one. So if AB belongs to R, if it belongs, what we have to say? That A and B work at the same place, obviously, right? If they belongs to R, they have to work at the same place. Now another if part is BC belongs to R implies if they are belonging to R, obviously B and C work at the same place. So where we have to approach? So we have to say that A and C work at the same place, and we have to say that A comma C belongs to R. So how to move from this part to here? So if A and B work at the same place, B and C work at the same place, it means that both A and C also working at the same place. If Rani and Tony works at the same place, Tony and Raju works at the same place. They're working at the same office or in some institution. Then obviously Rani and Raju also works at the same institution, right? So here what we can say clearly, A, B, C are working at the same place. They're working at the same place. So we got our answer that A and C work at the same place. Therefore, AC, this is what we have to prove. AC belongs to R. Therefore, R is transitive. So what is the conclusion here? The conclusion, the given relation R. So what is the relation? They have defined a set of all ordered pair such that X and Y work at the same place is reflexive, symmetric and transitive.